as JWST continues to blow our collective minds with the incredible, awe-inspiring pictures it releases. We've just got something a little different that's absolutely incredible despite being pretty fuzzy. It's the very first JWST direct image of an exoplanet, a picture of a world orbiting another star. It's kinda blobby, but it's also very awesome. JWST has gone and done something that, to be honest, I didn't even realize it could do. It's taken a direct image of an exoplanet. I think it was able to do it because this planet is relatively nearby and relatively massive too. So while it is incredibly faint, it's brighter than smaller planets or ones that are further away. Meet HIP 65426b. That's the planet you can see as the blob just here, orbiting its host star HIP 65426a. That's a capital A for the star and a little b for the planet. That's just how naming conventions work for these things. It's an incredibly large gas giant planet that lives about 400 light years from us and is between 6 and 12 times the mass of Jupiter. We're pretty sure that because it's a gas giant, it probably has no surface and can't be habitable, or at least it can't host any life that's anything like what we're used to. It would have to be life that is very different to that on Earth. We can't see the details of the surface here, we just see the light of the star reflecting off of the planet. We're being shown the images in 4 different wavelengths of light here, 2 coming from NIRCam and 2 from MIRI. Each of the instruments on Webb has a coronagraph to block the starlight of the host star and let us see the much fainter planet orbiting that star. For example, coronagraphs are also used to study the outer layers of our sun, letting us see the details there while blocking the overwhelmingly bright light from the sun. That's why the teams have drawn a little star here for us, just to show us where the star would be, but it's actually blocked and not visible in this image. In the NIRCam images, we can see 2 bar shapes near the planet, but those aren't real physical things. They're just artifacts of the telescope's optics. The planet is just one single blobby object in each image. It does look a slightly different shape in each one, and that's just because of the specifics of how each instrument moves light around and the different optical systems on board each one. They're so blobby because, astrophysically speaking, planets are really small, and even for Webb's massive 6.5 meter mirror, it's so hard to see them in any more detail than this. HIP 65426b is about 10,000 times fainter than its star in the near-infrared light that NIRCam can see, and a few thousand times fainter in the mid-infrared light that MIRI can see. These are different factors in part because stars are always fainter in longer wavelengths of light. NASA's Voyager spacecraft is the most distant probe we've ever sent out into the cosmos, and it's now traveling at an extremely fast 17.3 kilometers per second. But even at that colossal speed, it would take 73,000 years to reach the nearest known exoplanet to us. And this one here is even further away. Hence why they just look like spots of light to us. This one is also incredibly young compared to Earth, which is about 4.5 billion years old, while this new friend is a mere 15 to 20 million years old. It's a planetary baby, and this is a cool chance to study a world much earlier in its history than our own. This particular planet was actually discovered back in 2017 using the SPHERE instrument on the Very Large Telescope, yes, that's its official name, in Chile. But Webb's view is far superior to anything that's possible for ground-based telescopes because of the pesky interference of Earth's atmosphere. While this isn't the first ever direct image of an exoplanet, we've seen about 24 using various telescopes, including Hubble. The first time Webb does anything, all us astronomers do tend to get quite excited. In this very handy image, processed and annotated by William Balmer, you can also get a sense of how much further out this planet is from its star than we are from the sun. It's about 100 times further away than we are from our respective stars, and you can see that that would put it well beyond the orbit of Neptune, which only lives about 30 times further out than we do in our solar system. As a result, it takes HIP about 630 Earth years to complete one orbit of its star. That distance is actually pretty helpful here though, because it gives Webb more opportunity to actually separate the planet from the star, and it doesn't get quite as washed out by the starlight as it would if it was closer. Thanks to the data received, the team were also able to deduce that the planet has a temperature of about 900 degrees Celsius. That's 1,652 degrees Fahrenheit. For for those of you in the US, Cayman Islands, or Liberia, or those that just have a penchant for Fahrenheit over Celsius. Whatever floats your boat. But that's roughly the temperature of a candle flame, just all over the planet, all of the time. There's rumors too that the same team that gave us this image are also preparing to release an incredibly detailed spectrum of a brown dwarf. That's a failed star that never ignited, and they've seen a huge range of molecules in that atmosphere, including sodium, carbon dioxide, water, and methane. All in all, this observation shows us that Webb is continuing to work better than expected, and these data show us that it will be possible to image lower mass planets than ever before too. Speaking of spectra though, we have recently seen another spectrum from Webb 2, and it showed us that on the exoplanet WST-39b, there's a huge amount of carbon dioxide. That's what this bump here tells us. Many more spectra are on their way very soon, hopefully including the hotly anticipated TRAPPIST-1 system. But for now, we already have plenty to be excited about. Check out this video right here for more information about how JWST can actually take spectra of planets. This playlist here for all of the JWST videos I've made so far, and please consider subscribing if you're new here. It does help me out an awful lot. Until next time, stay safe team. I'll see you soon. Bye!